In this video, we are going to look at solving similar triangles. Okay, so our goals are first to do 2 examples of solving just for a basic missing side. And then we're going to do 1 example in context. So like a word problem. Let's first review what similar figures are, because we're actually going to use this definition to help us solve our problems. So 2 figures are similar if their angles are congruent, so their angles are equal to each other, right? And their sides are proportional. And that's really where we're going to focus today, is the fact that the sides are proportional. Okay, we can use that information to help us solve for missing sides in these problems. All right? And remember, proportional means that we have the same scale factor. So in this problem, we were multiplied by 7. So let's look at our first example here. It just says find the missing side. Okay, and here's our missing side here, x, and we want to find that missing side. Well, we have 2 triangles here. Before we can do anything, we need to confirm that they are similar. So we need to think back to our similarity theorems. Okay, I see we have 2 angles marked. So we have A and D that correspond, and they are congruent. C and F correspond, and they are congruent. We have 2 pairs of corresponding angles that are congruent. So these are similar by angle. Right? So if I know they're similar, that means that I know that all 3 of their angles are equal, are congruent, and their sides, their corresponding sides, have to be proportional, which means they're multiplied by the same scale factor. All right? So we just need to line up our corresponding sides. So I look at my angles to help me out. You can also kind of look at the shape, but don't rely just on the shape. 21 is between the 1 and 2 congruent marks. So x is in between the 1 and 2 congruent marks. So 21 goes with x, which leaves 24 with 16. Okay? So I can actually set up a proportion because I know the sides are proportional. I know that 21 divided by x has to be the same number as 24 divided by 16. If I divide these 2, it gives me the scale factor. And if these are similar, that means the scale factor is the same. So if I divide these 2, it'll give me the same number. And this is what we call a proportion. All right? So a proportion is when we have 2 fractions set equal to each other. Okay? And we can use that to help solve for the missing piece. Now, before I actually like to solve this, I like to simplify where I can. 24 over 16 can actually simplify here. I can divide top and bottom by 8, and that would give us 3 over 2. When you simplify beforehand, it just makes the math easier because your numbers are smaller. Okay, you don't have to do that part. So I'm just going to rewrite my proportion with my simplified numbers. 21 over x is the same as 3 over 2. So sometimes you can logically think through what the answer has to be without going through the mathematical steps. But if you can't do that, or your problem is a little bit more complicated, you can always solve a proportion with cross multiplication. Okay, cross multiplication. Okay, and we're literally going to cross our fractions and multiply as we do that. Okay. So I'm going to do x times 3, which gives me 3x. Now don't lose your equal sign here. That's the mistake I see most often. A lot of people want to then make it as a fraction, right? But this is an equation. We need it to be an equation in the end. So when I do 2 times 21 and get 42, it's the other side of my equation. It is not the denominator of my fraction. Okay? There are no fractions left when we cross multiply in this case. And then look, we just have a 1-step equation to solve. I just need to solve for x. So I am going to divide by 3, divide by 3. Okay? And you can use a calculator here if you need to. X is equal to 14. And if you weren't sure, you could always plug it back in and check yourself. Is 21 over 14 the same as 24 over 16? 24 over 16 simplified to 3 over 2. 21 over 14 simplifies to 3 over 2. So we are done. Okay? So that was just a basic idea of what the process is. Let's look at a more complicated problem. So the two triangles below are similar. In this case, I went ahead and told you they're similar. Okay, sometimes you'll have to check, sometimes it'll already tell you. It says to find x. So we're not even looking for a specific side measure, we're looking for a number inside of a side measure. So I want to know what x is, not what the side is. Okay? We have a big triangle and the small triangle. When I get problems like this, I find it easiest to separate the triangles. So let's see if I can do that here. Well, there's one. And there's the other. Okay, so I'm going to fill in the information that we know. We know in this small triangle it's x, v, y, and it's got 4x plus 12 on one side and 91 on the other side. And then in the bottom triangle here, it is x, w, z. And we've got 88 on one side and 143 on the other. You don't have to separate the triangles, but it helps you visualize what lines up. We need to find the corresponding parts in order to be able to set up our proportion. Okay? So if I look here, I know that the x is shared. So I know that angle is congruent. Okay? And I can also kind of go off the shape here. Right? That 4x plus 12 has to go with 88, and 91 has to go with 143. There are multiple ways to set up a proportion. Just make sure you're staying consistent. You know, small to big, or big to small, big to small. So let me set up that proportion here. So we said 4x plus 12 over 88 is going to be equal to 91 over 143. Okay. I got a proportion. I can cross multiply to solve. Be very careful when you're multiplying here. This 143 is multiplied to the 4x and the 12. So what you're really looking at here is 143. Oh, I forgot to simplify, right? What would 91 over 143 simplify to be? Yeah, it's divisible by 13. Which you may have just used a calculator to help you out, which is fine. And that would simplify to 7 over 11. Okay? So let me rewrite that. 4x plus 12 over 88 equals 7 over 11. Now I'm going to cross multiply. And when I'm cross multiplying, I'm going to write it out this way just so you can see what's happening. I'm actually doing 11 times this numerator. So that 11 will have to distribute. Equals, and then 88 times 7. Okay, and we'll simplify over here. So 11 times 4x is 44x. 11 times 12 is 132. And 88 times 7 is 616. All right, now we just have a two-step equation to solve. What would be your first step in solving this equation? Yeah, we want to subtract the 132. And that would give us 44x equals 484. And then I'm going to divide by the 44. And x would be 11. Again, you could plug in to check your answer if you weren't sure you did it correctly. Okay, so those were just two straightforward find the missing piece using similar triangles. Now let's look at it in context. This will be our last example. So Emma spikes a volleyball so that it bounces off the ground 4 feet away from her. So as I read this, I'm going to fill in the information into the drawing that they gave us. Okay, so it says that it hit the ground 4 feet away from her. That's going to be this horizontal measure here. Okay? Her hand was 5 feet off the ground when she hit the ball. So that's going to be our our vertical measure here. So 4 feet away from her, 5 feet off the ground. And the net is 6 feet beyond the position where the ball hit the ground. So here's where the ball hit the ground, and 6 feet beyond that is the net. So I know that this measure is 6. Okay. The ball bounced over the net, just grazing the top of it. how high is the top of the net? So we are looking for this measure here. All right. So now that we have all of our numbers and our variable in place, which are your first steps when you're solving a word problem, I've got to figure out how do I actually solve this. Well, I have two triangles here. Do you think they're similar? Okay, let's think about what theorem it would be. Well, a vertical and a horizontal line is going to make a right angle. So I have a right angle there and a right angle there. I have one matching corresponding angles. Okay, I don't have enough information on the sides to do side angle side or side side side. So I'd have to find another angle that is congruent. Okay, there's actually a little physics involved. When something is bouncing off of a flat surface, it's going to bounce off at the same angle. Okay, we see it with light and the way light reflects. Okay, we can also see it with the ball. Now in real life, there may be something that throws it off its path, but we are going to assume that this is a perfectly flat surface here, and it bounces at the same angle. So we can actually say that these two angles here are congruent. So now that we have two pairs of congruent angles, we can say it's similar by angle, angle. Okay? If the triangles are similar, then we know the sides have to be what? Proportional. So we can set up a proportion to solve this. Okay? So help me out here. If I do x is to 5, what would that be equal to? 6 over 4. Okay? Now I am just going to solve. Oops. And I would get 4x equals 6 times 5 is 30. And what would x be? Divide by 4. All right. And 30 over 4 is the same as 15 over 2, which would give us 7.5. All right. So we have found that the net is 7.5 feet tall. Anytime you're doing a word problem, make sure you relate it back to what the problem is talking about.